Hello, everyone. Today we're going to deal with a little bit of pseudoscience because I haven't done that in a while. There's this guy, Andrew, who sends me a lot of stuff, and it's a real big help a lot of times. And I'm thinking about maybe doing kind of like when he sends the stuff to me, just do it once in a while because my main focus on here is education. It's not really debunking. But I ran across something else. This one's something I ran across. It's right up there with the Devil's Tower's a tree stump, people. And yeah, but we're going to get into that here in a second. This is just a photo of me from 2018 before I got fat and old. And this was our first visit to Glacier National Park. There's me on the Sinclair dinosaur. There's a lot of shenanigans from the cats going on today. I hear construction in the basement, Romulus and Remus. So yeah, you might hear stuff in the background. But today, what we are going to talk about is this lovely little bit of bullshit from ancient history. We'll get into this in a second. The Temple of Hathor is a real place. It is in Egypt, but we'll get to that in a minute. But first, we're just going to sit here. I want you to look at this before I show you the stairs, just so you can, and we're going to point out the lies. And I'm just going to start calling them lies. I used to be cautious about that, but even if you don't know what you're saying is a lie, but you don't give a shit to do a simple search, then yeah, you're lying, okay? And anything with, ancient history, that's just a cover to sit there and say, I peddle bullshit. They're probably mud fossil people too, I don't know. But anyway, we're just going to deal with this. The staircase to the Temple of Hathor is a complete mystery to archaeologists. Number one, it's not true. It's not a mystery. And since it's dealing with the stairs themselves, which we're going to talk about what they're made of here in a minute, it's more falls under me, geology. It doesn't really fall under archaeology. Okay, but that's just ignorance right there. The steps of the staircase of the Temple of Hathor, located in Egypt, okay, that's true, are completely melted. That's a lie. That's just flat out right lie. Just because something looks like something to you doesn't mean it is that thing. Pareidolia, and I do this all the time. I love when people sit there and try to tell me Devil's Tower, or what was that name? The Jugthulera, tablelands in Tunisia. God, I did a whole video on it and I forgot what they're called. Are tree stumps, and then I show them, a photo of a rock that looks like a big dong, and I ask them if that's a giant's dick, and they never answer. But anyway, we got a big lie coming up now, which science cannot explain in any way. That's a lie, and I think I know what it is. Since they are built of solid granite, that's a big, big lie. They are not made of granite at all, okay? Matter of fact, they are made of what is the most common rock in that area, soft limestone. And the limestone's actually pretty pure. It's doesn't have a lot of clastics in it, so it's mostly carbonate. It's mostly CaCO3, and then we're going to come back to that because that's important. As where granites, as you know, are plagioclase feldspars, alkali feldspars or K-spars, and quartz mostly, with some little bit of mafics thrown in there of like pyroxenes and biotite and things as such, and those have an igneous origin, as where this limestone is sedimentary. And all this stuff is going to come into play. But yeah, when you write stuff like this, that just tells me you have no idea what you're talking about. Upon closer examination of the staircase steps, it becomes clear that their damage could not have been caused by erosion or normal wear and tear. Now, I'm going to chalk that one up to bias, because there are stairs. This is actually pretty common in stone stairs. As a matter of fact, there's a nice marble one in a place most people are familiar with. Let me see if I can find it. This is just from Wikipedia or Wikimedia, whatever. This shows you kind of what I'm going to be talking about here. But actually, let me show you. Let me scroll down here and show you what they're talking about. They're talking about these, and this is a crappy picture. Okay, you can tell it's a few years old. The resolution's not the best, But, you know, I mean, this is not a screenshot. I saved this. So it could be somebody's screenshot. I don't know. But we're going to deal with all this stuff here. Now, this is different from what people mostly think of who are familiar with this process here. Okay, but there's a famous place. Where are you? Oh, yeah. Right here. We're just going to do this Reddit one because I know this one. This is the Leaning Tower of Pisa. Okay, and these are marble, so they're just the metamorphic versions of limestone. And I think these might have some silica in them. I don't remember. But anyway, not the point. The point is, just from decades of people walking up and down these stairs, what you have is worn away. Now, some of it is actually just carried away, just erosion, mechanical. People's feet picking up molecules of carbonate and squashing them off. But that's not enough, because there are wooden stairs that are centuries old and don't have this. There's something else happening here. And those of you that know my structural geology videos know, like, I've seen my one about strain and stress and, you know, ductile deformation versus brittle deformation, elasticity, plasticity, and brittle failure. You guys know what a little bit of this is, and this has to do with plastic deformation. Just over the years of people walking up and down here, yes, they take a little bit away, but they also push down a little bit. And this is plastically deformed. Okay, first you have elastic deformation, which is like stretching a rubber band and bring it back. It goes back to its original shape. And all solids have elastic, plastic, and brittle deformation, okay? And they go in that order. And depending on how big each of these steps are, depend on what the material is made of. Now, stuff like marble does not spend a lot of time in the elastic stage, but it can in the plastic stage, and that's what we have going on here. And what is key to this is time. You know, if you had, say, 1,000 people did this over centuries, if you had 1,000 people run up and down these stairs once that they were brand new, this probably wouldn't happen. Not to this extent, because it's time. As people put that pressure on and they go up and down, they do this. Okay? Now, guys, could you not do that right now? Come on, stop it. Anyway, the Cat Wars. So this is for people going up and down these stairs over long period. You get plastic deformation. Now, what I just said about 1,000 people running up and down with these are brand new, you wouldn't get this effect. But if this was 1,000 people over 100 years, you might. That's because time plays a part. Just the fact that these stairs are now in the open air in an area that rains a lot and is humid is going to help change the properties enough. So one day of people running up and down here wouldn't do this, but 100 years, 200 years would. And time is important because you can extend the plastic range of something or shorten it depending on the environment it's in. That's why rocks can deform and form anticlines and synclines that don't have to break. That has to do with confined compressive strength and stuff like that. But I've talked about all that stuff before. But now you go back to this here, and what do you see? You see this. Now I'm going to show you where this is located. We're going to go right here because this is important too. Now, I did look up what the annual rainfall is here. It's only like 0.02 inches. So, you know, I don't even know how much that is in millimeters. What is that? 3 or 4? Anyway, it doesn't matter. 2.5. 5. I think it's 5. It doesn't matter. Anyway, the point is it's not a lot. But look at what we're by here. Right next to the Nile. And here you go from desert to crops. Okay? Now, what does that mean? Well, that means the Nile's here. That means we have groundwater here. And these stairs are located below ground surface. Where is it here? I think, is this it? Yes, the stairs of the underground crypt of the Temple of Hathor in Egypt lead down to a crypt that is underground. So these things are underground. That's important to figuring out what's going on here. Now, although the area itself is dry and does not see a lot of rain, the fact that it's wet right there plays a role. Because I tried finding something on the humidity in here, but just the fact that you're putting humid bodies in here over and over and over, and there's no way to get the air out, it's probably pretty humid down here. Plus, I'm sure in the past this has flooded. You know, just because it gets 0.02 inches a year now doesn't mean there haven't been years when you've had monsoons, okay, or monsoon type things, or just a big dump of rain. It happens once in a while. And that's key because moisture, water, what does that do to carbonate rock? It dissolves it. And if that water doesn't go very far, it redeposits it right away. I'm going to show you some, this is a specific feature I think you could classify it as. So as you can see up here, you got a combination of people walking. And the fact that this is even down a curve, but I think there's other pictures where it's right below and it shows some of the same features, I think. Let's see what that is. Yeah, you can see, come on, are you going to go there? Or no, you're not going to go there. But it looks like you get the same features here, and I think that looks like that's the outside. Anyway, most caves I've been in, man-made or otherwise, tend to be pretty humid. And although there's probably no water in here now, doesn't mean the human body hasn't precipitated enough to this, or it doesn't mean water hasn't gotten down here in the past. And people, their shoes, if you're wearing wet shoes or moist shoes, you know, that'll add to this too, although I don't generally think. I think the moisture for the humid foot is probably more than... Man, it is just fucking weirdo day here today. That's vomiting, and now I got to clean that up. Oh, guys, there's so many. I love you guys, but seriously, just seriously, anyway. Originally, probably sandals or bare feet would have, and the human body is very moist. It produces a lot of sweat and a lot of waste products that are water rich. And water is called the universal solvent for a reason, okay? So I think this is just a combination of plastic deformation over time and the dissolving of the carbonate rock, but it not going very far and being redeposited. And that's why it's thicker down here than it is up here, okay? And to me, that makes sense. And the fact that you got really dirty looking stuff here tells me that there's the kinds of dirt like this grime, if you've ever been in caves before and you've seen it, human handprints will do this after a while. It's part of weathering. And I mean, the human body, as much as whatever you think, it's pretty gross, okay? It really is. And, you know, and we leave gook behind when we touch stuff with our bare hands and stuff like that. It's just how we are, okay? We have a lot of sweat glands, a lot of sebaceous glands, all that other fun stuff. So this is just an example of carbonates experiencing plastic deformation, and then a combination of dissolving and being redeposited. If you don't think that's possible, I'm going to show you some really interesting pictures of stuff you probably aren't even aware that exists. Most people are aware of stalactites and stalagmites in caves. Most caves are dissolved carbonates. Carbonates have been dissolved out for some reason. Now, yes, there are lava tubes that form caves, but you don't get stalactites and stalagmites in them. Why? Because igneous rock doesn't dissolve well in water. Well, it does, some of it, but it doesn't form these structures because it doesn't. Anyway, the ions don't break up that easy. Anyway, they tend to form silicates. Now, a lot of people said the stairs at Hathor are what we call, not geologists, we don't use the word because it's just weird, and plus we don't deal with man-made materials that much. It's more of what engineers do, called geopolymers. But those are really ceramics and aluminum silicates. This stuff is not an aluminum silicate, and I guarantee you this rock has just about zero aluminum in it. Probably has almost no silicate in it because it's pretty pure carbonate as it is. So it's going to be prone to just kind of weathering in general. Okay, silicates don't give in to chemical weathering very well, and aluminum silicates, by the time they get down to that level, they're already weathered. So, I mean, granite isn't going to do this that easily. Granite's more likely going to mechanically weather at this stage before it chemically weathers. Most of our clays come from feldspars, and granites are feldspar rich, but they kind of need to mechanically weather first, except the mafic minerals, because the mafic minerals are not really stable at our surface. So that's why you'll see granites or little tiny holes in granites a lot, because that's where the mafic minerals have weathered out. But then the feldspars will get weathered, and they'll break apart, cracks, joints, fractures, and then the water does its thing. But it's not going to form something like this. Okay? It's not going to redeposit the exact same thing it just dissolved. Those feldspars are going to get dissolved, and they are going to react with other feldspars and make other things. So as we see here, what we see is different cave formations, all right, and they have different names. Well, I'm going to show you something pretty interesting here, all right, and here's your typical stalactites, and then your stalagmites, and everybody knows that, but look at this here, right down here. Doesn't this look melted? It's not. It's reprecipitated carbonate. And then you get your columns where stalactites and stalagmites meet. You get your flowstone. That's what this looks like to me. Flowstone. Okay, and there's the cave, and that's all it is it's dissolved and redeposited carbonate rock. And there's flowstone. And draperies are pretty cool. I gotta just show this to you. There's a drapery right there. Those are really cool. And you don't need caves to form these, because in Iowa, where I've been, there's a formation. I'm not going to give you the location because maybe I get too close to it. I don't want to give away the location because there's opali cephalopods there. Oh, maybe it's down here. Is it down here? No, it is not. Sorry, I forgot where it was. Where did I just do? Oh my. I don't know what I just did here, but anyway, it was a certain type of formation that looks kind of like a combination of drapes and big holes. It's kind of actually cool looking, but anyway, apparently I did close. I think it was in the National Park Service one, which is not that. So yeah. Anyway, I don't know what I did with it. That's this one too, and it's not in here. But anyway, I think it's just flowstone. It's just due to humans. It's not directly due to us messing with it intentionally, but I believe that this is just flowstone, like you would get in a cave, given enough time, and with some plastic deformation. That's what I think it is. So yeah. Anyway, that's it. If you have any questions or comments, please leave them below, and I hope you guys learned something.